Good morning, everyone. So today's topic is curve, and before that, we will solve a numerical based on magnetic field intensity to find how to find magnetic field intensity for sheet of current. Okay. So in last class, we have derived the formula for magnetic field intensity for current charge. So surface current density. Okay. So there is a surface current density is there. Is K. So value of H will be equal to half K cross A n. An is unit of vector. Okay. So H will be equal to half. This is surface current density. An is unit of normal vector. Let's first problem. So plane z is equal to 0 and z is equal to 4. Carry A is equal to vector A is equal to 10 AX ampere per meter. So plane Z is equal to 0. Carry current density of 10 AX per meter and A and minus 10 AX ampere per meter respectively. Okay. So you have to find the value of phi vector H at point A is 111, B point is 0 minus B. Okay, so plane Z is equal to 0. Let's suppose Z is equal to 0. This plane Z is equal to 0. And this is Z is equal to different color elements are there. Is that this is K1 is equal to 10x ampere per meter, and if it is K2, it is Z is equal to 4. So Z is equal to 4 carries minus 4 minus 10 x ampere per meter. Okay. So it is dot. This will be crossed. That means we have two sheets of current density. Okay. So current is sorry. So this is Z is equal to 0 plane, and this is Z is equal to 4 plane. Okay. So this is 10 AX. Okay. So current direction will be along positive direction. Like this. So this is K1 is 10x 4, K2 is equal to minus 10x. Okay, like this. So we have got two parallel infinite current sheet. So these are infinite sheet of current. And you have to find the value of H due to this current configuration at 111 and at 0 minus the 1. Okay. So 111. So we will concentrate at Z coordinate only. Okay. So this will be Z is equal to 1. Okay. So magnetic field due to this current element, let this H1, and due to this current element is H2. So total H will be equal to H total will be equal to H1 plus H2. Okay. So two current elements are kept. X is equal to 0. So K1 is equal to 10x and K2 is equal to 10 minus 10x at Z is equal to 4. And we have to find the value of H at 1, 1. So H1 is the contribution due to the this K1. First we will find H1. So due to K1 is equal to 10x, which is at Z is equal to 0. Okay. So H1, so we have derived this in last class, R vector cross A. Okay. So it is S1, so this will be K1. Okay. So this is K1. So K1 is equal to 10x, so this will be equal to R 10x cross A. Okay. So now we have to find the normal unit vector. So we can see these current elements, the sheet of current is kept at x is equal to 0 and z is equal to 4. So normal unit vector will be a z. Okay. So an here an will be equal to a. This will be a. So we are finding at h at 1 1. So we are concentrating on one with this coordinate only, z coordinate, z is equal to. Okay, so this will be 10ax cross az. Okay. So this is minus, and this is minus, and this is plus. So this is minus 10ax cross az. So this will be ax cross az is minus ay. So this will be equal to minus half into 10 into minus ay. So this will be equal to 5 and therefore, okay, so h will be equal to 5ay. due to K2, due to tan Ax at z is equal to 4 plane. So H2 will be equal to half K2 cross A. This will be equal to half. This is tan Ax cross Az. Okay, but we have to consider this convention of Az. Okay, so we have to find at z is equal to 1 and it is kept at z is equal to 4. Okay, so this is R2 and this is R4. Okay, so we always find A12 is R12 by magnitude of R12 is equal to R2 minus R1. Okay, so R2 is 1, here R2 is 1 and R1 is 4. So you will get R12 as minus 3 is. Okay, so this unit vector, the sign of unit vector is negative. So you have to consider as minus is. Okay, so now you will ask one question, sir, why we have not taken convention in this case when we are finding the value of h1? At this case, this is R2 and z is equal to 0 is R1. Okay, so R2 minus R1 is 1 minus 0, so it will give positive. Okay, so you have to consider this convention, okay, for finding the normal unit vector. Okay, so here first we have to find the value of h at z is equal to 1. Okay, so this will be R2, where you have to find the value of R2 or the value of observation, the point of observation is z is equal to 1. Okay, and the sheet of charge is kept at z is equal to 0. Okay, so this will become R1. So R2 minus R1, 1 minus, so this will be R1. So 1 minus 0 will give you positive Az. So in this case, it is positive Az. Okay. So when we are calculating for second point, second sheet of current, that is placed at Z is equal to 4. Now this will become R1 and this will become R2. So 1 minus 4 gives you minus 3 Az. Okay, so this will be minus 3. So we have to consider only sign. So this will be minus 3. Okay, so you have to remember this thing. So Ax cross Az is minus Ay, minus minus will become plus. So this will be y. Okay, so H1 is 5Ay. This is equal to 5Ay. Plus H2 is 5Ay. So net answer is 10Ay ampere per meter. Okay, so in this way. Next, we have to find h at 0, minus 3 and 10. Okay, so we have to consider this coordinate only, z coordinate, as it is kept along z is equal to 0 plane and z is equal to 4 plane. Okay, so from where z is equal to. Now this will become. Okay. So due to K1, so this is B part. you have to find a value of h at 0, minus 3, 10. Okay, so since the sheet of charge is lying along z-axis, on z-axis, so we will consider only the coordinate of z. Okay, so it is that coordinate is 10, so that is equal to 10, so this will become R2, where you have to find the value of h. Okay, so h due to vector h1 due to k1 minus ax at z is equal to 0 plane, so this will become h1 half k1 cross an. Okay, an will be az. So since it is along z axis, so an will be az. Okay, so keep here az. Now we have to consider its convention, its sign. Okay, so it is r2 and it is kept at z is equal to 0. Okay, so r2 minus r1. So r2 is 10 minus 0. So you will get plus 10. Okay, or A12 will be equal to R2 minus R1, magnitude of R2 minus R1. This will be by 10. AZ, A12, AN or A12 will be plus. Okay, so this is negative, so minus AY will get positive. Okay, now H2 due to K2, which is at z is equal to 4 plane and K2 is equal to x. Okay, so this will be again half K2 cross an. An is az. Okay. Now it is kept along z is equal to 4, so this will become r1. We have to find at z is equal to 10, so this is r2. Again it is bigger than r1, so 10 minus 4 gives you positive sign. So this will be positive. Okay. So ax cross ay is minus ay. So this is 5ay and this is minus ay. So for second case, so this will be minus, you will get 0 ay at 0 minus 3. So value of h is 0 at 0 minus 3, 10, and value of h is equal to 10 ay at 1, 1. Okay, so it will change according to the coordinates. Okay, so how to solve this problem? So you have to remember, whenever a night length of currency is given, you have to apply this formula. K is equal to half K1 cross Az. K cross Az. Okay, so if our current charge is there and we kept along y-axis and current is flowing along x-axis, so it is at y is equal to 0. So then Az, An will be equal to V1. Okay, so An will be that unit vector along which this sheet of current is placed. Okay, along which given in this it is at z is equal to 1 and z is equal to 4, so normal unit vector will be Az and this is, so this is how An. If it is along x, it is kept at x-axis and current is flowing into y-axis like this, then An will be Ax. Okay. K will be given in the question, and An, and how to find this convention, whether it is positive or negative. Okay, so if where you have to find that point will become R2, and where this surface charge is surface current is given, that will become R2. So subtract R2 minus R1 if you get positive. So this will become positive AY. If it is coming negative, that means it will be minus. Okay. In this way, you have to get the value of H. Okay. Now we will move. We'll find the expression of curl of H, or derivative form of Ampere's circular law. So in the last class, we are deriving, we're discussing the application of Ampere's circular law. So we had calculated the value of H for infinitely long right bearing conductor and for sheet of. So now next topic is current. Okay. So now we will derive the value of curl H using Ampere's circular law. Okay, so let's consider loop. Parallel x-axis, y-axis. Using the center of this rectangular, at this distance be delta y, and this distance delta x. So incremental length is delta x, which is parallel to x-axis, and this length is delta y, which is parallel to y-axis. Okay, so we are pursuing this incremental area with delta x. So we have to find the value of H due to some current, unknown current, which is enclosing this closed surface, and the value of H in the center of this loop, H is at the center H naught is equal to H naught Hx naught Ax plus Hy naught Ay plus Hz naught. So this is the value of H at the center of this. Okay, so value of H is equal to Hx naught Ax plus Hy naught Ay plus Hz naught X. Okay. So this is incremental closed path with length delta x and delta y. So and the surface area delta s is equal to delta y into delta z. Okay. So this is the total surface area of this incremental closed path. Okay, so we will use Ampere's circular law to determine the rate of change of H. Okay. So according to Ampere's circular law, line integral h dot dl. Okay, so we have to apply h dot dl to this closed path. Okay, so h dot dl can be divided into four integrals. So this will be from 1 to 2 plus 2 to 3 plus 3 to 4 plus 4 to h dot dl. And this will be equal to I and q. So we don't know the value of I here. Okay. So, but due to this, we have to find the value of h. So this I is unknown. Okay. So this h dot dl, closed line integral h dot dl, is divided into four integrals starting from 1 to 2, 2 to 3, 3 to 4, 4 to 1. So we are applying this empirical law to the path 1, 2, 3, 4, and again back to 1. Okay, so this h dot dl can be divided into four line integrals from 1 to 2, 2 to 3, 3 to 4, 4 to 1, like this. Okay, now we will find the value of line integral 1 to 2 h dot d. Okay, so from 1 to 2. So here the length is delta y. Okay, so from 1 to 2, if you integrate from 1 to 2 dl, it will be delta y. So value of delta L dl will be delta y. Okay, and let's suppose the current, sorry, the magnetic field intensity is hy. Okay, so this along y-axis, so this will be hy from 1 to 2. Okay, comma from 1 to 2 into delta y. Okay, so let's suppose the value of h from 1 to 2 is hy 1 to 2. Okay, so it is along y-axis, so this will be hy 1 to 2, and the length of this incremental area from 1 to 2 is delta. So what will be hy 1 to 2? It will be equal to. So the value of h at the center is hy now. Okay, according to y component plus. Okay, so we have to find the value of h at this line, this straight line. Okay, and we know the value of h at the center. Okay, so we have to travel this distance, this much distance. Okay, and we know that this length is delta x. Okay, so this length will be at the center of this loop. So this will be delta x by 2. Okay, so this will have to travel this length. Okay, so we have to find the value of h from 1 to 2, but the value of h is given at the center, which is for y-axis. This will be hy naught. Okay, so then we have to travel from the center of this loop towards 1 2. This is straight line 1 2. Okay, so distance will be traveled by this component of h will be delta x by 2. If it travels from this point to this point, so this will be delta y by 2. From this point to this point, again delta x by 2. From this point to this point, again it will be delta y by 2. Okay, minus delta y by 2. And it will be cross into the rate of change of delta y with respect to x. Okay, so here it is changing, the value of hy is changing with respect to x. Okay, so this will be the value of hy into. Okay, so substitute here, we get from 1 to 2 h dot dl is equal to hy naught plus delta x by 2 delta y by x. Okay. So now we will find the value of next line integral from 2 to 3. That's what from 2 to 3, 2 to 3. So again it will be hx. Now it is along x-axis. Okay, it is parallel to this x-axis. This will be hx from 2 to 3. Okay, and the length dl. So this length is delta x, but it is in opposite direction. So positive x-axis is this, and we are going from 2 to 3, which is in opposite direction of x-axis. So this delta x will be negative. Okay. If we come from 4 to 1, it will be positive delta x. Why? Because we are coming from 4 to 1, which is along positive y-axis. Okay. So now we have to find the value of hx 2, 3. Okay. So again, we know the value of h at the center with respect to x. So this will be x naught. Okay. So this is h naught is equal to hx naught x plus hy naught ay plus hz naught is x plus again we have to travel this distance. Okay, so we know the value of h at the center, but we have to find the value of h at this line from 2 to 1 at this straight line. Okay, so this will be equal to, again we have to travel this distance. So this distance will be, so this is delta y. So this is half of this. So this will be delta y by 2. So this will be delta y by 2 multiplied by rate of change of del x hx with respect to y. Okay, so h is traveling from the center of the loop to this straight line 2 and 3. So which component will travel? It is hx, and it will travel with respect to delta y. With respect to y. Okay. So substitute here. So from 2 to 3, h dot dl will be equal to x naught negative plus delta y by 2 del x by del. Okay. Then similarly we can find the value of integration from 3 to 4, from 3 to 4 h dot dl. Okay, from 3 to 4, so it will be similar to 1 to 2. Okay, because 1 to 2, which is x-axis, it is along y-axis. So this will be hy naught. Okay, and we have to travel a distance in this direction. So this is delta from 3 to 4. Okay, so this will be delta x by 2. Again, it is in negative direction or to the with respect to x-axis. So this will be minus delta x by 2. Okay, so you have to consider this convention. Okay, so we have to travel from the center to the line segment 3, 4. Okay, so we are traveling a distance x by 2, delta x by 2 in opposite direction to the x-axis. Okay, so this will be delta x by 2, and hy is traveling with respect to dx. So this will be delta hy by delta x, all multiplied by this length is delta y. delta. But this will be negative. From 3 to 4, we are traveling in negative direction of y-axis, so this will be minus delta. Okay. Then last line integral from 4 to 1, h dot dl. This is equal to. So this will be similar to this one, hx naught. Then we have to come to this form. Okay. So this length will be delta y by 2. Okay. And it is opposite to y-axis, so this will be minus delta y by 2. Differential length is delta x by delta y, okay, multiplied by delta x. So this length is delta x. So this is the value of h and this is the value of delta x. So we have calculated the 4 line integrals, line integral s dot dl from 1 to 2, from 2 to 3, from 3 to 4 and 4 to 1. Okay. So now we can calculate the value of h dot dl. Okay. So h dot dl, line integral, closed line integral, will be equal to, so this is hy naught plus delta x by 2 del h by del s whole multiplied by delta y plus from 3 to 2 is negative hx naught plus delta y by 2 del x y delta y. So this is delta x. Then 3 to 4, this will be negative delta y naught minus delta x by 2 del y by del x into delta y plus delta x naught minus del by 2 del hx del y. Okay, so this is hy naught into delta y. This is minus hy naught into delta y. So this will be cancelled out. It is minus x naught into del x. This is plus x naught into del x. So this two terms will get cancelled. Okay, and this is h by 2 delta x delta y by 2 del x by del y. And this is minus del x del y by 2 del hx by del y. Okay. This is negative, so this will become plus del x del y by 2 del y by del x. This is negative, so this will be del x del y by 2 plus del x. So adding this, so we will get, this will be, this is half, so this is delta x delta y is taken out, 2 will become half will become 1, so this is del x y by del x minus, this will be negative. So h dot dl is equal to dividing by this delta x by delta y. So h dot v divided by area delta x delta y is equal to minus delta x. Okay. So this is similar to cos law, where the flow surface integral v dot as upon volume is equal to the volume charge density. Okay. So h dot dl upon delta x delta y is equal to this much. Okay. And also we know that this is equal to I. Okay. And I delta I, sorry, delta I is equal to J into area, that is delta x into delta y. Okay. And this is what? This is I. So I upon area will be equal to J. So h dot dl phi delta x delta y is equal to del hy upon del x minus del x minus del y is equal to. So this will be in z direction. So this will be ordered to z. Okay. And we are assuming that delta x delta y is to be zero. This is very small area. Okay. So similarly, we can find the value of jx and jy. Okay. So h dot dl will be delta y delta z and this. This will be the value of jx. Okay. And similarly, we can find the value of jy also. Jy will be equal to limit delta x delta y tends to 0. Lowest line integral h dot dl divided by delta x delta y. So this both lines and this both sides. This will be delta x minus delta z. Okay. And we also know that J is equal to Jx Ax plus Jy Ay plus Jz Az. So this will be equal to delta Ax plus Jy is much plus Jz is this much. And this is similar to what? This is similar to cross product of H. Let's suppose cross product of vector operator with H. Let H is equal to Hx Ax. Let H is equal to Hx Ax plus Hy Ay plus Hz Az. So if you find vector operator curl of H, this is known as curl of H, or vector operator curl of H, it will be Ax, Ay, Az. Del by del x, del by del y, del y, del z. This is Hx, Hy, Hz. Since vector operator is equal to del by del x Ax plus del by del y Ay plus del by del z is, and H is equal to this much. Okay, so if you take the cross product of these two, vector operator and this H, so this is vector operator del by del x, del by del y, del by del z, and this is x, Hx, Hy, and Hz. Okay, and if you elaborate this matrix, you will get same result. Okay, so you will get same result. So this is equal to nothing, is equal to curl of H. This is also known as curl of H. Okay, so from this we can conclude J is equal to vector operator cross product of vector operator J is equal to curl of H. This is the relationship between magnetic field intensity and current density J. Okay, so curl of enter H is also equal to closed line integral. This is equal to J. This will be equal to divided by delta S and delta area. And limit delta S tends to so surface area is very small and it is shrinking towards this unit. Okay, so this is the relationship between J and H. Okay, so one thing you have to remember: dot product term, dot product with vector is divergence. Dot product of vector operator and the scalar quantity is gradient, and vector operator cross vector is curl. Okay, so you have to remember these three definitions of divergence, gradient, and curl. Okay, if you dot product a vector with a vector operator, you will give divergence. It will be a scalar quantity. Okay, dot product of vector component with a scalar, it will give gradient. It will be a vector. Okay, and cross product of a vector vector operator on a vector gives you curl, and again it is vector. Okay, so you have to know this divergence, gradient, and curl. Okay, so vector operator dot product on a vector gives you divergence, vector operator on a scalar gives you gradient, and vector operator cross product a vector gives you curl. Okay. So this is all about. So in next class we will see the physical significance of this H, and we will solve some problems. Okay. So any doubt?
और एक गलत नहीं आप कैसे समझे
कैसे? नहीं सर